Hey guys, so today we're going to be talking about the foundations of biology, which is actually chemistry. So atoms are the building blocks of molecules. So remember we said that the smallest unit of life was a cell. Well, cells are made up of molecules, which are made up of atoms. Okay, so it is important that we understand how atoms are made up so that we can understand how cells are made up and so on. Okay, so in this picture you have different elements represented by circular colored balls, and they are attached by rods to form molecules. So elements are basically where you have all of the same type of atom is an element. Okay, so this is a simple one. This is helium. Atoms are made up of protons, which are positively charged, so we think positive protons, and neutrons, which are no charge, so neutrons, no. And those are both in the nucleus, so protons and neutrons are in the nucleus. Then surrounding the nucleus, we have electrons, which are negative charges. Now, if you look at the periodic table, and I just pulled one off here, is carbon, and you can see that the atomic number is the number at the top. That is also the number of protons. And if the element is neutral, it is also the number of electrons. So for carbon, you have 6 electrons if it's neutral, and you have 6 protons in the nucleus. The mass number is protons and neutrons. So if you want to know the number of neutrons, you'll subtract the atomic number, or 6, from 13 and get 7. So there's 7 neutrons and 6 protons in carbon. This is a periodic table full of elements, which are pure substances that contain only one type of atom. And living things are composed of CHNOPS, which is CHNOPS, or carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. So those will be the ones that we'll be focusing on in biology class. So basically, electrons are going to exist in an orbital. Okay, so they go around the nucleus in a relatively orderly pattern to make it easy for us. So the orbitals can be in all different directions, but to make it easier, Niels Bohr came up with a model where we only show the, the first one is you have your first shell, which can only hold 2 electrons. The second shell holds 8. The third shell holds 8. And then it goes up from there. But we're really only going to be concerned about those first couple of shells. So for elements 6 through 20, an atom will lose or gain or share electrons in order to achieve stable configuration. So what we'll be talking about in the next video is all the different ways in which an atom is going to try to share their electrons or donate electrons, because what they want is to be full at their outermost shell. So for example, right here you have hydrogen. Hydrogen's outermost shell is just the first shell, and it only has 1 electron. So in order to be full on that first shell, it has to have 2 electrons. So hydrogen is going to go around looking for someone to share or donate an electron. So Bohr diagrams are going to help us figure out how many electrons fill the outer shell, okay? So you can have if your outer layer is already full, then that is considered a stable compound, and you are probably not going to bond with another element. So for instance, if you look over here at helium, helium has 2 electrons on their outer shell, which is actually the first one. So that means it's full. So helium doesn't really bond with anything else, okay, because it's happy. So the outer shell being happy, like in neon, it has 8 electrons, means that they are not looking to bond. They are very happy the way they are, and that is the most stable type. Okay. Elements in other groups have partially filled valence shells. And so they are going to try to be stable by either gaining or lose electrons with other elements.